Assalamu alaikum guys, welcome back. Okay, so we were doing period 3 and we did a few reactions before this lecture. Reaction of the elements with oxygen, elements with water, oxides with water. Now we are doing reaction of oxides with acids and bases, and in this lecture we are going to look at the types of oxides as well and the products that they make and the equations as well. So let's get started. Alright guys, so the first oxide of period 3 that we have over here, the first element is sodium, right? So its oxide is sodium oxide, sodium Na2O. We did make sodium oxide when sodium reacted with oxygen. Now the sodium oxide is a basic oxide. Okay, it is a basic oxide. Basic oxide means that it can react with acids to produce salt and water or salts. Okay, so now this is Na2O. It reacts with sulfuric acid, so it will give us a salt and water. Okay, sodium sulfate and water, and this is an equation you are expected to know. Then comes to let's come to magnesium oxide. Magnesium oxide is also a basic oxide. Okay, and when it reacts with sulfuric acid, it will give us magnesium sulfate and water. Simple and easy, and I'm sure you guys already know these. Okay, both of the key term over here to remember is that both of them are basic oxides. Okay, now coming to the third oxide that we have, the oxide of aluminum, which is Al2O3, aluminum oxide. Okay, this is an amphoteric oxide. What does the term amphoteric oxide mean? Okay, first of all, a very common question that the examiner asks from here is to give an example of an amphoteric oxide. First of all, he asks you an example. Al2O3 is the classical example, and secondly he asks you to define what amphoteric oxide is. So amphoteric oxide is basically an oxide that can react with both acids and bases. Okay, and amphoteric oxides are generally insoluble in water, generally. Okay, Al2O3 is also insoluble in cold water. Then coming to acids and bases, their reactions. So since I told you that amphoteric oxides can react with both acids as well as bases, so now let's look at the reaction of amphoteric oxide with both of them. Now first I have given the reaction of acid, and then I have given the reaction with a base. Now Al2O3 will react with sulfuric acid to give us aluminum sulfate and water. This is the reaction with acid. You need to balance the equation as well. So Al2 brackets SO4, and then there's a 3 outside, and then you need to balance it out. This is the balance equation that I've written over here. Then comes the next equation, and this equation is more important. That is the reaction of Al2O3 with an alkali or with a base. Okay, it reacts with sodium hydroxide when sodium hydroxide is taken to be hot and concentrated, and water molecules are also involved in the reaction. Okay, when all three combine together, they form this salt. Okay, this salt is known as sodium aluminate. You can call it sodium aluminate, or you can call it tetrahydroxy sodium aluminate. Now guys, this tetrahydroxy sodium aluminate, this name might seem a bit more complex than sodium aluminate, but now let me tell you something. This name is actually gonna be way more important and way more easier than the normal one. Why? Now just focus on the name. It says tetra. Tetra means having 4, right? Tetra means 4, right? Tetrahedral, 4. Hydroxy means it's referring to hydroxyl groups. So look at the formula. In this formula, you've got hydroxyl OH groups, and each OH group is actually, there are 4 OH groups in this formula, right? So tetrahydroxy and sodium aluminate. Sodium refers to the sodium and aluminate refers to aluminum. Okay, so tetrahydroxy sodium aluminate. 2 moles of tetrahydroxy sodium aluminate are formed when aluminum oxide reacts with hot concentrated sodium hydroxide, and it's an amphoteric oxide. And these types of oxides are very important. Okay, you must know that magnesium oxide and sodium oxide are basic oxides, and Al2O3 aluminum oxide, although it is a metallic oxide, but it's not a basic oxide, it's an amphoteric oxide. Okay, and this tetrahydroxy sodium aluminate is formed when it reacts with alkalis. Okay, so this pretty much completes the discussion on basic and amphoteric oxides. From the next lecture we are going to start out the reactions of acidic oxides with bases, of course. Okay, thank you.